Okay, this is the Math 1113 Zoom meeting, Friday, February 5th. And we're doing sections 5.1 and 5.2 this week. So I think we'll just start in with some problems from section 5.1. And let's see, my Fi is a little delayed this morning. Okay, so page 444. We are converting degrees to radians. Converting angles in degrees. To radians. Let's catch it up a little bit. It's a little better. Why don't we try number 7? 54 degrees. Oh, it's delayed a little bit. All right, so we multiply by pi over 180 degrees. You see the degrees cancel. Waiting for the Wi-Fi to catch up. It's caught up for a while, now it's delayed again. All right, so there I'm canceling the degrees, and I'm going to punch it out. It says round to 3 places. I'm waiting for the calculator to get up on the screen. There we go. Clear it off. .54 pi divided by 180. That to appear on the screen. And enter. Last Friday, the Wi-Fi was working perfect. 0.942, 3 places. Again, I don't put a degree symbol or anything, just put nothing. 3 places. Look at the 4th place is a 4, so we round it to 3 places. All right. So then in the next section, let's try 21. Convert 3, and this would be in radians, to degrees. So we take 3 and multiply by 180 degrees divided by pi. So when I multiply that out, 3 times 180 divided by pi. Hit enter. One hundred 71 point, doesn't really say how many places to round it to. We'll call it 89. 171.89 degrees. Now, this makes a good point, especially if you picture this. I meet people, everything's in degrees. So they see a 3, they still think it's degrees. So it's very important to understand, this makes perfect sense to me. I'll draw both pictures. See how that's just short? That's less than 180 degrees. So 3 being equal to 171.89 degrees is here. This is pi at 3.14. This is in radians. 3 radians. 3 degrees is here. Just above 0. I've exaggerated a little bit. This probably, if you actually measured it, probably 15, 20 degrees, but just trying to exaggerate it. The 3 degree, you could barely tell 3 degrees above 0 if I did it actually accurately. So I hope you get the difference between the two. 3 degrees is in the first quadrant, barely above 0. 3 radians is in the second quadrant, barely above pi. This difference would be 0.14 radian. This angle would be 3 degrees. Wi-Fi is catching up better. All right, very good. All right, what about coterminal angles? This is still page 44, 444. Coterminal angles, let's try 31. 3 pi over 4. Oh, this is better. I won't talk about it too much, I don't want to jinx it. 2 positive, find 2 positive and 2 negative coterminal angles. All right. Well, you want to stay in the same system. I mean, you could convert it to degrees and then find a degree and then convert them back to radians, but we'll just stay in the same system. Remember, you want to add 2 pi. Well, with the common denominator of 4, that's going to be 8 pi over 4. 2 pi over 1 times 4 times 4, 8 pi over 4. All right, so 11 pi over 4, we'll call that answer 1, first positive. First, positive. Same thing again, plus 8 pi over 4, and you'd be at 19 pi over 4. Second, positive. Answer 2, if you want to call that. All right, you want 2 negative. Hey, the Wi-Fi is working much better now. 3 pi over 4, subtract 8 pi over 4. You'd be at negative 5 pi over 4. First, negative, coterminal. Okay, subtract 8 pi over 4 again, and you'd be at negative 13 pi over 4. Second, negative, coterminal. Okay. So then in 35, that section, we already did 35. Let's see if 39 are 155 degrees, 8, 75 degrees, coterminal. I would answer it. Basically, you got it's the same idea. They're just giving you the two, basically the answer results, and you just basically add 360 in degrees. See if you can get to 875. If you can't, then they're not coterminal. 155 degrees, add 360 degrees. You're not going to get to 875 on once around. This is going once around. You're clearly not going to get to 875 once around. 155, add 360, and you get to 515. So try adding 360 again. And I'm at 875. Yep. Dyslexic today, 875 degrees. Yes, coterminal takes 2 times around to get to it, but yes, coterminal. You could have also started at 875 and subtracted 360, and yeah, you'd have come up with 155. So you can do it either way. All right. Find, try one like 45. Negative 800 degrees. Find coterminal between 0 degrees and 60 degrees. All right, wherever negative 800 is, without drawing the picture and figuring it out, it's hard to know. But we're going to add 360 to get back to negative 800 degrees, and we'll add 360. Add 360, and we're at negative 440. Clearly still below 0, not between 0 and 360. In fact, adding it again isn't going to get you to, because 440 is bigger than 360. Is it still going to get you? It's still going to be negative. Add another 360. It's the second time around. Add 360. We're at negative 80 degrees. So one more time, negative 80 degrees, add 360 degrees, 240 maybe, add 360, 360 straight, 280, oops, I didn't do that in my head. So 280 degrees is coterminal with negative 800. Hope you then know that's in the 4th quadrant, because the y-axis is 270 degrees, so 280 degrees would be here, negative 800 degrees is here, negative 440 degrees is here, and negative 80 degrees. You can see the negative 80. You're at 360 here. So that's got to be 80 degrees. So in the negative direction, you're at negative 80. It makes perfect sense to me. All right, so 47, that little group of problems ask you to Find a coterminal between 0 and 2 pi. Coterminal. Let's try number, we'll try 51. 17 pi over 4. Find angle between 0 and 2 pi coterminal. All right, well, you're going to, it's 17 pi over 4, you're going to subtract, well, I could call it 360, that's a different system, but 2 pi. Once again, denominator is 4, so times 4, you'd be at 8 pi over 4. So that would get you to 9 pi over 4. 0 and 2 pi would be 0 to 8 pi over 4. So we're still just above 2 pi. So once again, 8 pi over 4 minus 8 pi over 4, a full circle, and you'd be at pi over 4. So 17 pi over 4 is coterminal with pi over 4 in the first quadrant, which would be equal to 45 degrees. Once again, this makes perfect sense to me. All right, the rest of the problems are about just the formulas. And the two formulas you need to know really are arc length, S equals R theta, and area is 1/2 R squared theta. Again, theta in radians. So if we go to, let's try one in degrees. Let's see one, well, 58, just to show you what happens. Say 58, now we're on page 445. Find S. Theta is 40 degrees. S. Theta is 40 degrees. Radius is 12 meters. All right, so if you want a picture of that, 40 degrees just below 45. You're finding S, that arc. That's not a right angle there. That's an arc along the right angles back here. This is not about that. And your radius is 12 meters. So your S is R theta, which would be 12 meters for the R, and then 40 degrees. Now, the thing is, if you just multiply that, you get a nonsensical number, and it has units of meters degrees, which is nonsensical. Nobody knows anything in meter degrees. So you can convert this separately if you want, and then bring the number in. I just kind of do it all at once. You're going to multiply that 40 degrees by pi over 180 degrees, and you can just multiply it all at once. And you will come out in meter because your degrees cancel. This is unitless. You'll come out in meters. So I got, if you can see both. Put both on the screen. Okay, I've got 12 times 40 pi divided by 180. Oh, just in a Zoom. 8.377. Okay, notice it's less than 1 radian. Remember, at 1 radian, the S would equal 12 meters. So 1 radian would be, remember, it's 57.3 degrees. So you see how 40 degrees is less than 57.3? So that's going to make the S less than 12, which it is, less than 12 meters. Again, perfect sense to me. All right, why don't we try 67 is another one with degrees, and it uses the area formula. Area of a circle, Central angle is 140 degrees. We're trying to find area. 40 degrees. The area, I'm not trying to find a guy, I'm butchering this. The area is 70 square meters. We want to find R. If you wanted to picture this, you can just plug and chug it, but 140 is into the second quadrant, short of 180. You'd be going back. There's your R. This angle is 140 degrees. And this total area is 70. So area equals 1/2 R squared theta. 1/2. Yeah. Okay. I'll just go ahead and plug and chug the numbers here. So the area is 70 R squared times 140 degrees. And once again, multiply that by pi over 180 degrees to get it to radians. Okay, you multiply both sides by 2, giving you 140. If you want to get the number here, 14 pi over 18, or 140 pi divided by 180, 2.443. Okay, we can divide both sides by 2.443. This will have a little bit of round off error, probably from the book. $57.3. All of a sudden the Wi-Fi slowed down a little bit. And so square root of 57.3 is the square root of R squared. I'll twist it around. The R then is the square root of 57.3. 7.5696, call it 7.57. I didn't say meters. We are working in meters. I don't rip you if you don't put the meters. All right, why don't we start with 5.2 then. Find your exact values of trig ratios. Why don't we try something like number 7? This is off page 453. Number 7, they've twisted the triangles in every different situation. I'm just going to straighten it out. This is the right angle, and they put a 2 here, and they put a 3 here, and a theta here. I don't know why they twist them in every different configuration. Hope you know how to get the hypotenuse. 2 squared plus 3 squared would equal hypotenuse squared. Four plus 9 would equal hypotenuse squared. 13 would equal hypotenuse squared. So I'll twist it around. The hypotenuse then is the square root of 13. Since this is our beginning, I'll just remind everybody this is opposite, this is adjacent, and this is hypotenuse. So they want all 6 trigs, the sine of theta, opposite over hypotenuse, 2 over root 13. Cosine theta, 3 over root 13, adjacent over hypotenuse. Tangent, opposite over adjacent. See it? Okay, and then the other threes, just simply flip them. It'd be root 13 over 2. Secant theta, root 13 over 3. Cotangent theta, 3/2. All right, so that's the 6 values of all, or the values of all 6 trig ratios. Why don't we punch something like 11b. Evaluate cotangent of 23 degrees. On the calculator, degree mode, no cotangent key, so it's punched 1 divided by tangent, 23 degrees. All right, let's see if we're in degree mode. We are. 1 divided by tangent, 23. You don't punch degrees. If you're in degree mode, it takes the 23 to be degrees. 2.3556. What does that mean? It's not just some random number. It means at 23 degrees, your y over your x, this is equal to the ratio of the y to x, the y leg to the x leg at 23 degrees. It means your y leg is 2.3556 times your x leg. That's all it means. The cosine of 20, I could write down the decimal for cosine of 23 degrees. That would be the direct length of the x leg. The sine of 23 degrees would give you the direct leg of the y leg, etc. All right. Find an x page 453, 19, 36 degrees, 12, and x. We want to find 5 places. Gotta get a little anal. Well, notice you have opposite over adjacent. That would give you a tangent. 12 over x. In effect, you can exchange these places. X would equal 12 over tangent 36 degrees. If that's too fast, you multiply by x, the x can divide by tangent 30, divide by tangent 36. In effect, the x and tangent 36 change places. You can also think of it as cross multiplying. X times tangent 36 would equal 12, then you divide by the tangent 36. Once again, you want to be in degree mode. I'm sure I still am. 12 divided by tangent 36. 16.52. Oh, I'm supposed to have 5 places. 3, 4, 5. Yeah, 51658. All right, let's see. Sketch a triangle. Let's try 25. Sketch a triangle. Cotangent theta equals 1. Find the other 5 ratios. All right, well, I do it off the tangent theta. It would also be 1 because it flips 1. You flip 1, you don't change. So really you have 1 over 1. tell this would be the square root of 2. The square root of 1 squared plus 1 squared. 1 plus 1 is 2, square root of 2. So I can get the bottom row real quick. Right. Sine theta is going to be this 1 over root 2. Cosine theta will be this 1 over root 2. They're going to be the same thing because this actually is at 45 degrees. Remember, when your legs are equal, you're at 45 degrees. Cosecant will be root 2, and the secant will also be root 2 over 1. You don't have to write the over 1. All right, let's see. Evaluate an expression. It says without using the calculator. You can go ahead and use the calculator. What they want you to do is something like this. It's page 454. Sine of 30 degrees, cosine of 60 degrees, add a sine of 60 degrees, cosine of 30 degrees. All right, we made this special angles. I don't know if you have them memorized. You can look back at the table and get them. This table right here. We tried to show you where these come from in Tuesday's video. Just to show you the useless crap I have in my head. A sine of 30 is a half. A cosine of 60 is also a half. A sine of 60 is root 3 over 2. And a cosine of 30 is also, the long leg is also root 3 over 2. So this is going to work out 1/4 plus 3/4. And that'll be 1. All right, now if you think that's magic, once again, degree mode, you can just punch it straight and just double check. Have a degree mode, okay. That's the worst thing in trig is you do everything right, but you happen to be in the wrong mode of the calculator, so you get wrong answers. All right, I'm supposed to go sine 30, cosine 60 plus sine 60 cosine 30. Anybody want to give me a drum roll? If not one, I'll quit on the spot. It's a miracle. 1. Okay. $37 about solving right triangles. Why don't we try something more complicated about like 47? Do one of those. So you've got a vertical there. This side's a little shorter, 60 degrees, 100 on the vertical, 30 degrees over here. And we're supposed to find x. This entire length. So you're going to have to make up some other ratios here. You can do, this is going to be right angle. You can do either leg. In fact, you're going to wind up probably doing both. And I don't know if you want to call this one A and this one B, and then you'll wind up taking the sum. So there's lots of different ways to do this. If I start with tangent of 60, I get 100 over A. And A then is equal to 100 divided by tangent 60. And I can punch that out right now if I want. And I play the same game over here. The tangent of 30, call this one number 1, this one number 2. The tangent of 30 is 100 over B. So again, the B and the tangent change places. B is 100 over tangent 30. And so your X would be A plus B. Total sum of those, which would be 100 tangent 60 degrees, add 100 tangent 30 degrees, and I can punch it all at once. Divided by 10. I didn't check the mode, but I haven't changed it. 60. And add 100 divided by tangent 30. 230.94. I haven't checked any answers today, so I'll see if I'm an idiot today. 5.2, it was 47. $230.9. Oh, they said around one place. That's right. 230.9 right there. They said around to one place. Like I say, I won't do a true or false answer based on this or 230.9. We'll make it more obvious than that. That's pretty much examples of about everything. So I am going to go ahead and call an end to the Zoom meeting. And hope y'all do well. Look for the quiz today. Quiz 3. Quiz 3, 10 problems. Section 1, 5.2 with Google form. Available today. All right. Hope you have a good weekend. Thank you.